What is the meaning of differentiation? Differentiation is a basic idea in calculus. It's about finding out how something changes when something else changes. In simple words, differentiation helps us find the rate of change of a function, such as how fast or how slow something is happening at a certain point. If you draw a graph of a function, the derivative will tell you the slope of the graph at any point. The slope also is the same as the slope of a tangent line that touching the graph at that point. The derivative of fx with respect to s is written as f prime x, or df over dx, and it's also defined as f prime x equal to f x plus h minus fx over h with h approaches 0. What is the technique of differentiation? So here are 4 techniques of differentiation. First of all, we have derivative of constant, which the constant of a function is always equal to 0. Next, we have derivative of sum and difference. Then we have product rule, and lastly is quotient rule.
So for question 2a, the equation is y equals to 3x squared sec x plus 2. So as we can see, this is the product of two functions. We have 3x squared and sec x plus 2. So we're going to use the product rule. So then we assign the parts. U is equals to 3x squared, while u prime equals to 6x. For v equals to sec x plus 2, and v prime equals to sec x plus 2 tan x plus 2. So we apply the formula until we got the final answer. So the final answer for 2a is 3x squared sec x plus 2 tan x plus 2 plus 6x sec x plus 2. So for question B, 2b, y equals to 4x plus 2 over cos x. So for this question, the function is a fraction, so we are using the quotient rule. So now we assign the parts again. U equals to 4x plus 2 and u prime equals to 4. For v equals to cos x and v prime equals to minus sin x. So we substitute into the formula until we get the final answer. But before we going to get the final answer, we need to make sure that we simplify it already. So for this question, the answer is 4 cos x plus 4x plus 2 sin x over cos 2x.
Okay, so for the question 3, given y ln 3x minus e power of 2x plus 1 minus tan 4y equal to 0. Find dy dx using implicit differentiation. So first, we need to determine which expression need to use product rule, quotient rule, or differentiate as usual. So for this case, y ln 3x need to use product rule because that has two variables. So for the first expression, we need to use formula u v prime plus v u prime. So we will get y times 1 over x plus ln 3x times dy dx. So for the next expression, we need to differentiate as usual and we will get 2e power of 2x plus 1. And the last one is negative 4 secant square for y times dy dx equal to 0. So next step is we need to separate and group the expression with dy dx and put on the left hand side, and the others we need to put on the right hand side. So we will get ln 3x times dy dx minus 4 secant square 4y times dy dx equal to 2e power of 2x plus 1 minus y over x. So we need to factorize the dy dx on the left hand side, and we will get dy dx times ln 3x minus 4 secant square 4y equal to 2e to the power of 2x plus 1 minus y over x. So with the calculus method, we will get the final answer. dy over dx equals to 2e power of 2x minus minus y over x over ln 3x minus 4 secant square 4y. Thank you.
For question 4, use linear approximation to estimate the value of square root 4 80.99 minus 2 over square root 80.99 correct to 3 decimal places. So here is the solution. We will use formula for linear approximations, which is f of x naught plus delta x equals to f of x naught plus differentiation of f of x naught times delta x. First, we substitute 80.99 with x. So we are going to let f of x equals to square root 4 of x minus 2 over square root 2 of x. To make it easier, we will make f of x equals to x to the power of 1 over 4 minus 2x to the power of negative 1 over 2. Next, we will differentiate f of x. f prime of x is equal to 1 over 4x to the power of 3 over 4 plus 1 over x to the power of 3 over 2. As we know, x is equal to 80.99. To find the answer, we need to have initial value, which is x naught. 81 will be the initial value since it is the most nearest value to 80.99. For delta x is equal to x minus x naught. Next, we substitute all the value into the formula and calculate it. The answer will be 2.778.
Okay, so for the conclusion, by solving this question, we learned that the core concept of differentiation, finding the rate of change of equations, and master key techniques like the power, product, quotient, chain, and implicit differentiation rules. We apply this to handle complex functions, use implicit differentiation for equation involving x and y, and practice linear approximation for numerical estimates. Overall, this exercise strengthens our calculus skill and prepare us for more advanced topics.